Hello, today we are going to talk about solving logarithmic equations. So, before we do that, let's do some practice from the last time. So, if we need to find logarithm on base 2 of 800, how would we solve it? First of all, we can write this as log of 800, which is basically base 10, and divided by log of 2. So, this is the formula. And then all we need to do is change this log of 800 into 8 times 100. So 100 we can write like this. And then log of 2. 8 is basically 2 exponent 3. So I can write this as uh, uh, log of 2 exponent 3. And then this I can write as log of 10 exponent 2. So here I will have divided by log of 2. So then I will have this. This I can have as 3 log of 2 divided by log of 2 plus 2. Okay. So this log of 2 and log of 2 cancel out. So I will have an answer of, this is again for all of it. So like this. So my answer will be 3 plus 2 over log of 2. So this is the final answer. Uh, this is basically 800 divided by log of 2 because we changed from log base 10 to log of 2, and then we solve it. Now if we want to do the same similar problem, let's do this one. So this is log of base 5 of 12,500. So first of all, uh, let's just again write this as log of 12,500, which is base 10, divided by log of 5, because we changed from log 5 to log 10. So now we can split this as log of 100 plus log of 125. So 125 we can write as 5 exponent 3, and then we divide it with log of 5. So log of 100 is basically log of 10 exponent 2, and also we can write this as 3 log of 5, and we divide all of this with log of 5. So now log of 10 exponent 2 is basically 2. So it will remain as 2 upon log of 5. And then this log of 5 will cancel. So we will have plus 3. So our answer is 3 plus 2 upon log of 5. Log of 5 you can always calculate using the calculator. So you can do with log of 2. So you can have a number, but I'll just leave it here and then move on to the key points. The first point says use the rule that you cannot take the logarithm of a negative number or 0 to check for extraneous solutions. Now remember, for an equation you may have a solution which when you check it may not satisfy the equation. It may not work well with the initial original equation, so you call such a solution as an extraneous solution. So whenever you have a negative number or a 0 inside the logarithm, that means it is undefined. So that is an extraneous solution. So make it a habit to look for extraneous solution if there is any. Also, equations need to be in the form log base b of y equals L before using the definition of a logarithm to rewrite in an exponential form. So, like I said, you take this b to the other side, uh, then b it becomes the base, L becomes the exponent, and then you have that equal to y. From there, you can solve and check for extraneous solutions. The third point is if equations can be rewritten in the form log base b of y is equal to log base b of z for expressions y and z, then you can use y equal to z to solve and then check for extraneous solutions. So it's exactly the opposite of taking the logarithm on both sides. So if you have log on both sides, you can just get rid of the logs from either side and go ahead and write your final answer and then check for solutions. So with that, let's move to the teacher model today. And if you look at the example 1, it says convert the following logarithmic expressions into equivalent exponential expressions. So uh, since there is no number here, that means base 10. And if we change it to the exponent form, we say that 10 exponent 4 is equal to 10,000. So now I have changed this logarithmic expression into an exponential expression. Similarly, here this is a common log, so I can say that this is base 10, exponent 1 over 2 is equal to square root of 10, which is basically the same thing. Again, if you have log base 4, 256 equals 4, then you can rewrite this as 4 exponent 4 is equal to 256. And you can see that 4 times 4 is 16, 16 times 4 is 64, and then 64 times 4 is 256. Now, log natural of 1 is equal to 0. Now, in this case, if log natural is coming from the exponent base e, so if you have e exponent 0, that is equal to 1. So here log natural will have a base e, we take this e that side, 0 will become the exponent or the power, so e power 0 is equal to 1. So that is how the 4 problems from example 1 are solved. From here, you should be able to see how we can change a logarithmic equation into an exponential equation. Okay. And similarly, if you want to change from an exponential expression to a logarithmic expression, you can do that. But just see how we have done it in all these 4 problems. Let's do example 2. Write each of the following equations as an equivalent exponential equation and solve for us. Anyways, there may be a typo, but anyway. So what we do is basically, first of all, we see that we have a log term on one side, and can we change the other side into a logarithmic form? So if we see, we can write log of 3x plus 7, and log of 1 is 0. So if we write log of 1 is basically 10 exponent 0. So log and 10 cancel out, so we get 0. Now we have the log on both sides, so simply we can write this as 3x plus 7 equals 0. I'm sorry, 10 exponent 0, and that is equal to 1. Okay. Now, if we get rid of this 7 from both sides, so we subtract 7, and we end up with 3x equals negative 6. Then we divide both sides by 3, so we end up with x equals negative 2. Okay. Now at this point, once we have this solution, we use to check whether it is a valid solution or is it an extraneous solution. So I will check my answer. So if I input this value, I will have log of basically 3 times negative 2 plus 7. So 3 times negative 2 is negative 6, plus 7 is plus 1. So it's a positive number. So we can say that yes, this is a valid solution. So I will just write it at valid solution. The valid solution is exactly opposite to an extraneous solution. Now, the second problem, let's do that. And it says log base 2x plus 5 equals 4. So now log base 2x plus 5, can we write this as um, 2 exponent 4? No, we can just simply write this as let's write it as like this. Now, if we change it to an exponent form, then we will have x plus 5 is equal to 2 exponent 4. So that is 16. Once x plus 5 is equal to 16, we just subtract 5 from both sides. So we end up with x equals 11. Okay. Once again, if we insert 11 into our initial term, 11 plus 5 is equal to 16. So this is also a valid solution. So far, we are getting valid solutions, but very soon you will start seeing some problems where our solution may not be a valid solution, but rather an extraneous solution. Okay. So now let's do this problem. Log base 2 of x plus 1 exponent 4 is equal to 8. Okay. When we change it to the exponent form, we will have x. First of all, we can take 4 outside. So x plus 1 we leave within the log. Log 2x plus 1. 4 comes out is equal to 8. Then we divide both sides by 4. So we get rid of that exponent. Log 2x plus 1 is equal to 2. Now, when we change this into an exponential form, this 2 goes there, and that 2 changes to an exponent is equal to x plus 1. And this is basically equal to 4. So x plus 1 is equal to 4. We subtract 1 from both sides, and x is equal to 3. Okay. So now, when we have x as 3, 3 plus 1 is 4. So 3 plus 1 is equal to 4. So log of a positive number is fine. So that means it is a valid solution. Okay. All right. So in these problems, what we are doing is we change the logarithmic equation to an exponential expression, and then we simplify and we solve for x. And once we get the value of x, we just confirm if it is a valid solution or not. Okay. So let's go to example 4. And it says solve the following equations. Now, here I have log natural x plus 2 equals log natural 12 negative log natural x plus 3. So this is a number. These are the terms involving x. So instead of you solving it as it is, let's just try to move this thing to the other side. So what we do is basically we add log natural of x plus 3 on both sides. So these two cancel out, we will have log natural of x plus 2 plus log natural of x plus 3 is equal to log natural of 12. This is the same as log of xy is the same as log of x plus log of y. Okay. Now join them together. So we'll have log of x plus 2 times x plus 3, and we just leave it as log of 2, log natural. Then we can get rid of the log and we multiply these. So x squared plus 5x plus 6 is equal to 2. So now we just used another property which says that if log of x is equal to log of y, then x is equal to y. So we did the same thing. Now we need to get rid of this 2 from here. So we subtract 2 from both sides. X squared plus 5x plus 4 is equal to 0. 4, when we want to factorize it, 4 can give us 1 and 4. So I will have x plus 1 and x plus 4 equals 0. And I will have x equals -1 and -4. Now these are my two solutions. I need to check if any of these solutions is an extraneous solution or not. So when I say x is equal to -1, so x equals -1, then among these terms, x ln log natural of x plus 2 and log natural of x plus 3, both are positive. So x plus 2 and x plus 3 are positive. Okay, so if they are positive and they are neither 0 nor negative, that means this is a valid solution. If x is equal to -4, then x plus 2 becomes -2, which is less than 0, and x plus 3 is equal to -1, which is again 0. So we say that this is an extraneous solution and this is the real solution. So x is equal to -1. This is valid. And x equals -4. This is an extraneous solution. Okay. We have to rule this solution out because this is not the right solution. So now I'm going to just make a boundary because it is just the extension of the top problem. And let's move on to the second part. So now when we have this equation, all we need to do is if we need to change that negative sign will make it go to the denominator. Okay, so if I solve it further, I'll take this to the other side. So I will add plus log natural of -x on both sides. Okay, let's do it that way. So if I do that, then I will have ln of x plus 2 square is equal to ln of -x. Okay, this side cancels out, this goes there. Then I remove the log natural from both sides, so I will have x plus 2 squared equals negative x. Then I open this thing up, so I will have x plus 2 multiplied with itself, x squared plus 4x plus 4 is equal to negative x. Then I just add x on both sides. So x squared plus 5x plus 4 equals 0. Now this is my quadratic equation. I need to find the two factors for 4, which are 4 and 1. So I can simplify this as x plus 1 times x plus 4 equals 0. Quite interestingly, I get the two values x equals -1 and -4. Okay, so now when I have this particular scenario, wait a minute, let me go back to this problem one more time, because I just noticed that I changed this from log 12 to log of 2, which was wrong. So basically this is 12 and then this is 12, so you'd subtract 12, and also here you subtract 12, so this is 1. Okay, and this becomes -6, and then everything changes basically. So when you factorize this for -6, you can get 6 and -1. Okay, 6 and -1 will give you -6 when you multiply them, and sorry, -6 and no, +6 and -1, and +5 when you combine them. So you will have x plus 6 and x -1. So from here, I will probably, this check part, I will leave it here. I'll just, so I'll go here. X is x -1 and x +6. So x will be +1 and -6. Okay, these are the two solutions. When I have -6 here, -6 plus 2 is -4. So log of a negative number doesn't make any sense. Again, this is not the solution. I'll have to discard this, and my solution will be here is x is equal to 1. So this is the answer here. X is equal to 1. That is my valid solution. X is equal to +1 is valid. X is equal to -6 is an extraneous solution. Now, here, when we do x -1 and -4, when x is equal to, check, x is equal to -1, then -1 plus 2 is 1, which is positive, and negative times -1 is also +1, so it is positive. So this is my correct solution. And if I have x is equal to -4, then x plus 2, -4 plus 2 is -2, which is less than 0. So this is an extraneous solution. So x is equal to -1 is my valid solution. Okay, only this is my only valid solution, because the other solution turned out to be an extraneous solution. Okay, so this is how you do it. Just to recap, because we had a mistake, a little bit mistake on the first problem. So log natural of x plus 2 is equal to log natural of 12 negative log natural of x plus 3. We add this term on both sides, so this cancels out from here. Then we have log natural of x plus 2 plus log natural of x plus 3 is equal to log natural of 12. These two can combine using this property, log of xy is equal to log of x plus log of y, and then we can get rid of the log natural from both sides. So x plus 2 times x plus 3 will give us x squared plus 5x plus 6, and that is equal to 12. Then we rearrange, we take care of 12 from here, bring it here, it becomes negative 12. So we have x squared plus 5x negative 6 equals 0. For negative 6, we found the two factors plus 6 and negative 1. So it's going to be x negative 1, x positive 6. We have two possible solutions for x as 1 and negative 6. Now, to find out, we need to insert these values in place of x in the terms involving the log or natural log. So, when you have negative 6, negative 6 plus 2 is negative 4. Your log natural becomes undefined. So, negative 6 cannot be a solution. Plus 1, on the other hand, can be a solution because 1 plus 2 is 3, that is positive. You can find out the log natural for that. And 1 plus 3 is 4, again a positive number for which you can find out the log natural value. So x is equal to 1 is your valid solution. The second problem, we just took log natural of negative x to the other side, and then we got rid of the log natural. We had x plus 2, entire thing in parentheses squared equals negative x. We opened it up, we solved it. We got again two solutions, x as negative 1 and negative 4. Negative 4, when you insert here, negative 4 plus 2 is negative 2. You cannot find the log natural for a negative number, so you have to discard this solution. This is an extraneous solution, and x is equal to negative 1 is your only valid solution. So this is how you do these problems. These are the independent practice problems that you should be doing. So log base 2 of 256 equals 8. Log of x plus 2 equals 3. So you change logarithmic expressions to exponential expressions and then solve. In this case, uh, you just combine the log terms here and then try to come up with another log term here and then get rid of log from both sides, so you can further solve it for x. And then once you get the value of x, if you have one or more values, you always need to confirm if it is a valid solution or if it is an extraneous solution. So there are 5 problems that I expect you to do exactly the same way I did the teacher model, and then complete your assignment and turn it in. With that, I complete this lesson for today. Thank you very much. See you next time.